Hello learners, today we will discuss about electrophilic aromatic substitution in amines. As in the previous lecture we have discussed about the nomenclature of amines and method of preparation of amine. Today we will discuss about the substitution pattern in amines. Consider here, this is amine. First we will consider the attack of electrophile at position 2. At second position, if this is the functional group, consider the case here. This is the first position, this is second position. When an electrophile attack at this position, this bond will be used by this electrophile. So when this is attached to this position, a positive charge will be created here at this carbon. A carbocation will be generated here. Okay, in the next structure, when this positive charge appear at this carbon, this bond will shift at this position due to resonance, and again the positive charge will be created, and the positive charge will be created at this position. This carbocation will be formed. After this, in the next resonating structure, this electron pair will shift here and new positive charge will be created at this position. After that, in this case, when H positive will be removed and this bond will be displaced here, and we will get these resonating structure when an electrophile attack at this second position. This is called ortho position. Okay, next we will consider the attack of electrophile at C3 at meta position. This is first position, second and third. This bond will be utilized by this electrophile, and this get bonded to this carbon, third position, and the positive charge will be created at this carbon. Okay, in the next resonating structure, this pair will shift here and positive charge will be created here. In the next resonating structure, this will displaced here and we will get positive charge here. See here, we will remove H positive and this pair will shift here. These are the resonating structure in case of electrophile when attack at meta position or C3. Next we will consider attack of electrophile at para position. Consider the case here. This is first, second, third and fourth. This is the fourth position, also known as para position. Electrophile will use this double bond and get bonded to this para position. After bonding at para position, a positive charge will be created at this carbon. Again, due to resonance, this bond will shift here. Okay, and the positive charge will be created here. In the next resonating structure, displacement will be this side and we will get a positive charge on this side. In the concluding structure, when we remove H positive, this bond will shift here, and these are the resonating structure in case of para position. As it is clear, when we consider the attack of electrophile at ortho, meta and para, we have concluded that from above this structure, the NH2 group is strongly activating and ortho para director. Hence, a number of side reactions also occur. Therefore, there is always a need of protection of amine group, and this is done by acetylation. If we attack this aniline, first we consider the example of halogenation. When halogenation is done, Br2 in aqueous, when treated with this aniline, we get a product in which these all ortho and para positions are bonded by this bromo, this substituent. Okay, if we want to prepare ortho or para isomer, first we have to protect this NH2 group, and this NH2 group is protected by acetylation. Consider the example. We will treat this amine with acetic anhydride and this will get attached here. This is the acetylation of amine. By acetylation of amine, we can make the amines less reactive, or when this group is protected by this and we take the halogenation again, then we will get only ortho and para products. Not all the positions are blocked. Okay, this is the protection of amino group. Next, consider the nitration. Nitration is usually done when we will treat the compound with HNO3 in the presence of sulfuric acid. Direct nitration leads to oxidative products in addition to nitro compound. So first we protect the NH2 group. How we will protect? By treating this with acetic anhydride. This is acetylated amine. Then we will perform the reaction of nitration, HNO3 in the presence of sulfuric acid, and we will get this nitrated product. Okay, we will hydrolyze, and this again we will get NH2 group. Next is the case of sulfonation. How we will perform sulfonation? By treating the compound with sulfuric acid. This is sulfuric acid, H2SO4, and we will get this product. When this is treated with at 453 Kelvin, we will get para isomer of this sulfonic acid group. This is actually the zwitterion structure. See here, consider the example of zwitterion. What is the zwitterion? Sulfenilic acid is also known as zwitterion because it contains both acidic and basic group. Therefore, it would not be unexpected if these groups reacted to form an intramolecular salt. Thus, it exists largely in the form of an internal salt in which hydrogen ion from sulfonic acid group has been taken by amine group. This type of internal salt is known as dipolar or zwitterion. Okay, this was all about the electrophilic aromatic substitution in case of amines. Thank you, students.